Welcome to this special edition of Frequency Matters, the RF and Microwave Update Series. I'm Pat Hindle, and today I'm talking with David Kiesling and Kai Lo of Times Microwave Systems. Welcome, guys.
Hi.
Thanks, Pat.
Pat, yeah, thanks for having us.
So I've talked with Times several times about markets for demanding environments such as space and hypersonics. So I really wanted to drill down on the specifics for cables used in the space market. What are the challenges of using RF cables in space?
For the most part, space, if you look at the traditional space and the new space, as we call it nowadays, there are some main challenges that really haven't changed. Size, weight, and power consumption, those are still very much big concerns in today's space market. Whether you are building a bigger high throughput satellite or the smaller LEO satellites, those are the swap concerns are still by and large a huge requirement and challenges for many interconnect products. And on top of that too, because space is such a harsh environment, there are unique challenges that we probably do not see in terrestrial-based applications. Multiplexing is one of those that actually come to mind. And then the other big challenge that I think NASA and all the other space agencies have been quite aware of for decades is the outgassing performance. How some of the polymer materials will outgas and how over time it will impact the other space components within a payload.
You have the radiation, you have reliability, and so forth. So, when Kai mentions the harsh environment, it's across the board, and you also have the challenge where you can't fix it. So it better work the first time, and it better work for decades in some situations, right? Some of these far-reaching spacecraft have been operating for 10, 20 years. Look at the Hubble spacecraft, for example. So, space is certainly a challenge.
So with all those challenges, what materials and construction techniques are used to make the RF cables, that are suitable for these space applications?
Yeah, for every one of these challenges that we mentioned, some of them do have some sort of common denominators. There are materials that definitely good to cover and check most of the boxes. But then there are also design techniques that we have to pay attention to. Just take multiplexing as an example. The materials is certainly a factor. The surface finish that we choose for interconnect products, those that does by and large determine the level of multiplexing performance a product can have. But on top of that too, there are geometric relations that we need to consider when it comes to the prevention of multiplexing. And when it comes to outgassing and radiation resistance, there have been some pretty extensive study done over the years to establish a fairly good library in terms of what materials will perform well in a vacuum environment with a low outgassing performance. So all in all, it is not different when it comes to coming up with a good space products compared to many other applications that we have to deal with. And nowadays, it's really for the most part concentrating on material selections and good design techniques, right? Understanding the geometric relations between how electrical performance and mechanical requirement could impact each other. So all in all, there are no easy silver bullets, so to speak, right, to come up with a perfect space product. It is always a give and take, push and pull type of relationship, understanding a full requirement and the environment that the product is going into, and then coming up with the best balanced, reliable solution possible using the best materials available as well as the design techniques.
Yeah, so what are the performance requirements for RF cable assemblies in space, and are there any additional special requirements that are not typically done in other applications?
Yeah, I think the radiation environment is certainly one of those. So as with any RF interconnect, it's loss, phase stability, power handling, and so forth. So all that applies in space like it would with any other RF assembly. But then it really comes back to this environmental challenge that you have. And so if you look at the radiation, resistance, it's very hard to resist radiation. It's more about surviving in a radiation environment. We have materials like Tefcel for jacketing. If you're outside fully exposed, you're going to use more of a semi-rigid type of cable with a copper outer conductor. And so I think it really depends where you are in the spacecraft to drive what your design requirements are going to be. Sometimes you're in a fully enclosed situation where the radiation isn't as great. If you're there and we see that, then you can use more traditional designs because you don't have that challenge. But the problem there is space is so limited. So what we're seeing is a trend to smaller and smaller cable sizes to minimize the weight, the space, and so forth, to really optimize the design for all the things that Kai mentioned here at the beginning, to really minimize all those design challenges that you have.
So what are some of the different types of RF cable assemblies that are available for space applications?
So traditionally, we're using more PTFE-based cables adapted to the environment, but the most common cable we're selling today are our PhaseTrack family of cables. So the same types of requirements you have on the terrestrial side, multi-element antenna arrays and so forth, and the phase criticality that you have to maintain to make sure your antennas and communication systems work accurately, apply there as well. It's actually even more stringent because you imagine you're a little tiny spacecraft way up there. There's no room for error when you're trying to pencil in on that antenna up there. So the PhaseTrack materials meet the requirements for being in space for all the different things that Kai mentioned, outgassing and so on, and they provide the phase stability over a very broad temperature range. Because that's something we haven't really mentioned. You think about going around the Earth, you're going to be in sun, and then you're going to be in dark, deep space. And the temperature range you see when you do that is really severe. So it's not like it just gets a little cool, right? It gets really cold. And so you want to maintain that performance across that temperature range as well as all the other things that we mentioned before.
And so what are some of the future developments that you see for cable technology for these type of applications?
Yeah, I think one thing we're excited about is we have a new connector family called it's a locking SMP connector. We call it TLMP, because one thing we didn't mention is launch. So on top of everything we just said, you need to also survive this high vibe and high shock environment as you're getting up into space. And so, I mentioned the reliability, and you want to make sure when it gets there, it's working right off the bat. So we've done some development on locking connectors, both as individuals and in shells with multi-connectors inside of them, so that you ensure that your connection is perfect when you get up into space. So it's taking those materials, it's looking at them in different ways for reliability and so forth. And I think the other side of it is on the size of the cable. So a lot of the demand we're seeing today is on 047 size cables. So and there's 47 thousandths of an inch in diameter when I say 047. They're very small. But can you push the boundary even further? I wouldn't be surprised if we're going to see volume applications for the next size down into 034 as they really try to optimize. So that's the other areas that we're going. It's really going smaller and smaller and smaller because if you distribute your array, you can get smaller power handling, less power handling for each one. And if you can pull it tightly, that really small cable isn't going to impact your design nearly as much, and you can really save some weight. So it's continuing to reduce weight. It's looking at smaller and different geometries, and then providing that in a reliable package. Those are the trends. And, again, like I mentioned, with locking connectors and smaller size cables, those are the two things we're really focused on right now.
Well, thank you so much, David and Kai, for talking with me today about space applications with the cable assemblies. It's a very tough environment, so it's a kudos to you guys for making such great cables that last such a long time. For our audience, you can find more videos at videos.microwavejournal.com. Thanks for watching.